There's a number of astrophysical measurements, observations, astronomy that tell us that there's more matter in the universe than what we can see with our telescopes. It turns out when you look at the gravitational pull on galaxies and stars in the universe around us, that the matter that we can see through light, stars and this sort of thing, the matter we're familiar with, only accounts for about 15% of what is actually out there. 85% of the matter in the universe, the stuff that actually holds together galaxies and the clusters of galaxies in the universe that we know, is made up by some non-luminescent material, which we refer to as dark matter. We would like to know what that is, discover it, and study it. It's sort of the underlying composition of what formed the universe that we see today. Our theories of how the universe evolved basically posit that there must have been some seeds of gravitational material, matter, early in the universe where all of what we call our galaxies and stars today formed around. And that has to have been the dark matter. So if dark matter did not exist, then we would not exist today in any form that we recognize. The universe would still just be filled with hydrogen and helium gas. So there are a number of different ways that one can try and detect dark matter directly. There's actually a whole zoo of different technologies that are being developed. Because dark matter has not been yet discovered, people don't know exactly what the right way to do this is. The experiment that we've been working on uses a type of radiation detector, a germanium radiation detector, which is made of a germanium crystal about this big, about the size of your fist. And these detectors are very sensitive to particles, typically radiation, but also potentially dark matter, striking the germanium atoms, the nuclei inside the crystal, and measuring the ionization charge that's created by that. It's basically the electrons flowing out like an electrical pulse from the detector. So this is a particular detector design that we've been developing here at PNNL for a number of years in terms of making them more sensitive. You know, they can measure smaller signals, lower background in terms of being able to measure events that happen even more rarely in comparison to all of the natural radioactivity which these detectors are sensitive to. I am thoroughly excited by the idea that we are discovering things about the universe that we did not know, 10, 25 years ago. Just the pure discovery of it. I am enthralled by the idea that some of the technology that we developed to be able to answer these big questions can sort of quickly be turned back around and handed over to people who want to use it on a daily basis for solving issues of everyday import. To me, it is just the perfect mix of work, and I just think about every day that I get to wake up and be able to do these sorts of things.